Welcome to today's machine learning class, and in this class we will see the Naïve Bayes classifier from third unit, Bayesian concept learning. That is the part 1 of third unit. And in this class we will see what is Naïve Bayes classifier and steps to solve the Naïve Bayes classifier. After that we will see one example, that is the football World Cup match on the basis of past performance data of playing teams. Okay, this is our textbook example. Let us see all those things one by one. Naïve Bayes classifier. It is a simple and most effective classification algorithm based on supervised learning. Okay, because already we know that supervised learning is having two major categories. First one is classification and second one is regression. Okay, Naïve Bayes classifier is a classification problem, hence obviously it will come under supervised learning. Okay, it can solve the high dimensional training data set problem. That is, if the data set is very high dimensional, that is number of dimension is more, then obviously we can select the Naïve Bayes classifier. It is based on Bayes theorem. Bayes theorem. So it is also called as probabilistic classifier, because the Bayes theorem is used to predict based on probability of an object. Right? It helps to build fast machine learning models that can make quick predictions. And it also part of family of generative learning algorithm. Generative learning algorithm. That means it seeks the model, the distribution of input of the given class or category. That is, inside the class data, that is input data, that input data will be distributed. And some of the popular Naïve Bayes algorithms are spam filtering, sentimental analysis, and classifying articles, etc. That is, for text classification, we can use Naïve Bayes algorithm. Here, a person has height 182 centimeter and weight 68 kg. Now, we need to find whether this person belongs to basketball player or not. Okay, what is the probability that this person belongs to basketball player? So, this can be predicted by using Naïve Bayes classifier. Okay, because different players are there, different player classes are there, and now we need to predict whether our person A belongs to basketball team or not. Okay, so this is known as probabilistic classification. So based on the probability of this particular person, we need to classify whether he belongs to basketball team or not. Naïve Bayes classifier steps. First we will see what are the steps there to solve Naïve Bayes classifier, and then we will see one example how to solve those problem by applying all those steps one by one. Right? Step 1. First, construct the frequency table. Construct the frequency table against the target outcome. Okay, from the given input data, we need to construct the frequency table for each and every attribute of the given input. And step 2, identify the cumulative probability for target attribute equal to yes and target attribute equal to no. Okay, on the basis of all the attributes. So this is step 2, that is multiply probabilities of all favorable condition drives yes and all favorable, that is non-favorable condition to drive no condition. Okay, this is step 2. And when come to step 3, here we need to calculate the probability through normalization by applying the formula, that is probability of yes, which is equal to P of S divided by P of S plus P of no. And the second one is P of no, that is probability of no, which is equal to P of no divided by P of S plus P of no. Here all the applicable data will come. Here only no and here only yes. The P of S, this one, that will give the overall probability of favorable condition in the given scenario. Okay, and the P of no, this will give the overall probability of non-favorable conditions. Which are the non-favorable conditions in the given scenario? That will be identified by using P of no. And this is the example for our Naïve Bayes classifier to predict the outcome of football World Cup match on the basis of past performance data of the playing team. Okay, this is our problem. Now the training data is given, okay, in the table. This is training data, okay, and here 4 parameters are considered. So weather condition is first parameter, and wins in last 3 matches second, humidity is third, and one loss is fourth one. Win or loss is fourth one. Okay. When come to weather condition, 3 different classes are there. Okay. This is rainy, overcast, and sunny. Okay. 3 classes of data are there. When come to matches 1, the second attribute, again 3 different data are there. 3 matches and wins 2 matches and wins 1 match. Okay, when come to humidity, 2 classes are there. First one is high humidity and normal. Okay, when come to last one, this is true or false. Only 2. False, true, false, true. Okay, only 2 data. So by using this particular given training data, we need to predict whether the team will win the match or not. So this is our target attribute. And now we have to use this Naïve Bayesian to classify the conditions when this team wins, okay, wins the match, and predict the probability of this particular team winning a particular match when weather condition equal to rainy, weather condition, this particular weather condition is rainy, and 1 to the last matches, to winning in the last matches, humidity equal to normal, humidity equal to normal, and they won the toss in the particular match. They won the toss also in the current match. Okay, so these are the conditions, and now with these conditions we need to predict whether the current team will win the match or not. The first step is construct the frequency table. The frequency table is drawn for each attribute against the target outcome. Here the attributes given are 4. First one is weather condition, and second one is win in last 3 matches, that is the second one. Third one is humidity, and fourth one is win toss or not. Okay, so for all the given attributes we need to construct the frequency table. So this is the frequency table. So these are the frequency table. So this is the frequency table for weather condition, and win last 3 matches, and third one is humidity, and the last one is win toss, okay, true or false. So these are the frequency table for all the given 4 attributes. First let us see how to construct the frequency table for weather condition. So when come to weather condition, there are 3 categories of data. First one is sunny. So this is sunny and overcast. 4 overcast are there, and rainy. Rainy are 5 rainy. 1, 2, 3, 4, 5. 5 rainy data are there. Okay, now we need to compute in the 5 sunny records how many lies on win the match equal to yes, and how many lies on win the match equal to no. Win the match equal to no. Okay, so totally 5 records. 3 sunny records lies on yes. Okay, so this is sunny, yes, yes, and here this is yes. So 3 sunny records lies on yes, and 2 sunny records lies on no. Okay, so here this is no, and the last one is no. Last one is no. Okay, and when come to overcast, all the 4 overcast lies on yes side. Okay, 4 lies on yes side, hence 0 in no. And when come to rainy, totally 5 rainies are there, 2 comes under yes side, okay, and 3 comes under no side. So rainy yes is here and another rainy yes is here. Okay, 2 rainies are in yes side and 3 are no side. 1, 2 and another rainy no is here. Okay, and so totally when come to weather condition, 9 records lies under yes side and 5 records lies under no side, one the match, with respect to one the match. Okay, likewise we need to compute one in last 3 matches, that is the second attribute. Here also we are having 3 different categories, 3 wins, 1 win and 2 win. Okay, when come to 3 wins, 4 records are there. Here 2 lies on yes side and 2 lies on no side. And when come to 1 win, 6 records are there. 4 lies under yes side and 2 lies under no side. When come to 2 wins, 4 records are there. 3 lies under yes side and 1 lies under 4 side. So when come to won the match, that is win in last 3 matches, yes are 9 records and no are 5 records. Okay, and next let us take humidity. Humidity is here. Here 2 different categories of data, high and normal. 2 different categories are data. Okay, 7 records are high side and 7 records are normal side. Okay, if it is high, 3 records comes under yes side. Okay, 3 records comes under yes. See, high equal to yes, 1, 2, high equal to yes, high equal to yes. Okay, 3 records comes under yes side and 6 records comes under normal. Okay, normal side, this is 1, 2, 3, 4, 5 and 6. 6 records comes under yes side and 1 comes under no side. So this one. Okay, likewise we need to compute win the toss, true or false also. Win the toss false, 6 records comes under yes and 2 records comes under no. Okay, false no, false no, and this is another false. Okay, 2 records no side and all the other false are yes side. And when come to true, 3 records comes under yes side and 3 records comes under no side. When come to true, see 1 no, another no, this is another no. Okay, 3 records comes under no side and the other 3 records comes under yes side. So totally 9 records will come under yes side and 5 records will come under no side. So this is how we need to construct frequency table. After constructing the frequency table for all the given attributes, next we will move to step 2. Here identify the cumulative probability for one match equal to yes and the cumulative probability for one match equal to no on the basis of all the attributes. Okay, this is one method. Otherwise, simply we need to multiply the probability for all favorable conditions that will derive yes side or all favorable non-favorable conditions that derive no conditions. Okay, this is step 2. Okay, so to predict whether the team will win for the given condition, this is our problem, isn't it? So which condition the team will win, we need to predict. First one is weather condition is rainy. So the weather condition is rainy and win in last 3 matches is 2 wins. So here this is 2 wins and humidity equal to normal. So humidity equal to normal and win toss is true. Win toss equal to true. So with these condition we need to predict whether the given team will win the match or not. So now we just try to write the Bayes theorem with respect to our problem. Okay, the probability of win match gives A1, A2, A3 and A4. which is equal to probability of A1 and A2 and A3 and A4 gives win match into probability of win match divided by probability of A1 and A2 and A3 and A4. Okay, now we know that the probability of A and B, which is equal to probability of A into probability of B, isn't it? Hence, this particular Bayes theorem can be rewrite into this formula. Okay, so the probability of A1 and A2 and A3 and A4 gives win match can be rewritten into this form. Probability of A1 gives win match, A2, A3 and A4. After that, the probability of win match divided by P of A1 into P of A2 into P of A3 into P of A4. Right. And here the values for S can be taken from the frequency table. The frequency table is given here for all the given attributes. Okay. Now P of A1 gives win match divided by P of A1, isn't it? So that is A is rainy, A1 is rainy. For rainy, S is 2, isn't it? So total number of S in the weather condition is 9. So 2 by 9. 2 by 9. Okay. And the second one is wins last 3 matches. Here wins equal to 2 wins. So when come to S, this is 3. Hence 3 by 9. And the third one is humidity. Okay. Humidity is normal. So normal that falls under S is 6. Hence 6 by 9. And the wind toss that is equal to true. 3 records falls under S condition. Hence 3 by 9. And finally this one, P of win match. So P of win match means total number of win equal to 9. Total number of win equal to 9. Okay, and total number of records are 14. So 9 by 14. Okay, so the result is 0.010582011. So this is for yes. Simultaneously, we have to apply the same formula for no also. Okay, one match equal to no. Okay, so A1 gives not one match. Okay, A1 is rainy not one match is 3. Okay, and total number of no is 5. Okay, hence this is 5 by 3. Sorry, 3 by 5. And second one is the attribute is win in last 3 matches. So in win in last 3 matches, for 2 wins, no will fall only one record. Okay, so total number of no in this one last 3 matches is 5. So 1 by 5. Okay, and when come to humidity, normal only one record lies on no side. Okay, so here also total number of records are 5 under no. Hence this is also 1 by 5. And one toss. So here true is 5. Sorry, true that will come 3 records under no side and total number of records are 5. Okay, hence 3 by 5. And finally P of not one batch. So total records are 14 and 5 are no. Okay, so this is the given value and we will get 0.005142857. Step 2 is over. Now step 3. In step 3, normalize the above two probabilities, that is yes probability and no probability. We can ensure the sum of these two probability is 1. Okay, that is probability of yes and plus probability of no, which is equal to 1. Okay, so probability of win match, which is equal to probability of win match divided by win match plus not win match. Probability of win match plus probability of not win match. Already we got the value for win match, that is yes, and not win match, that is no. Okay, so simply we need to substitute those values into this formula, then we will get 0.672948, and this is for no condition, not win the match. So probability of not win match, which is equal to probability of not win match divided by probability of win match plus probability of not win match. Okay, the denomination is same value, okay, which is equal to 0.327052. Okay, and now let us conclude our problem. From our computation, we can identify that 67% probability, that is the positive S side value is 0.672948, isn't it? So this is 67% probability of the team will win the match if the above condition becomes true for that particular day. Okay, based on our condition on that day, the probability of winning the team is 67%. Okay, and hence the Naïve Bayes classifier provides simple but very powerful way to consider the influence of multiple attributes on the target outcome. Multiple outputs. So here also in our problem we used 4 different attributes on target attribute, isn't it? Target outcome. And it refines the uncertainty of the event on the basis of prior knowledge. Okay, already we have the training data. Okay, if we give the very good training data, then it refines the uncertainty of events. Okay, on the basis of the prior knowledge, that is the training data, and it is able to simplify the calculations through independent assumptions. Okay. So far we have seen the Naïve Bayes classifier from the third unit Bayesian concept learning. In this class we have seen what is Naïve Bayes classifier and the steps to solve the Naïve Bayes classifier. That is, there are 3 steps, and we have seen all the 3 steps to solve example, that is football World Cup match example. Okay, so based on the past performance data of the playing team, right? So in the next class we will see another important topic from third unit. Thank you.